So changing the base case was a useful generalization to make induction easier to use. Are there any more generalizations? Here is something that's called strong induction, even though in fact it's not stronger than normal induction. You cannot prove more with it, it's just some proofs are a little easier. So remember our well-ordering proof that every amount greater than 7 can be paid with 3s and 5s. There we looked at 3 cases, n equals 8, 9, and 10. And in our induction proof, it was pretty different because we only looked at essentially one case, one base case. But then we needed to have a slightly more complicated argument in our induction step. So let's look at the dominoes again. So induction tells us that if you drop the first domino and if every domino knocks down the next one, then all dominoes go down. But in fact, if you look at it, by the time you get to domino number k, all the dominoes up to that point should be down. So we could also say, and I'm not giving a proof here, but that's equivalent, that rather than assuming that the previous domino went down, you could assume that all the previous dominoes went down. And that makes some proofs quite a bit easier. Sometimes in this case you will also need to use several base cases, but actually sometimes we use several base cases with normal induction, sometimes we use only one with strong induction. That's not really what makes it strong. What does make it strong is the assumption that states rather than the previous domino fell down, P of k minus 1 was true. It says all the P of I from the base case all the way up to k minus 1 were true. And from there, from that seemingly much stronger assumption, then we would derive that P of k must be true as well. So let's try to prove the statement that we already proved 2 different ways, that every amount greater than 7 can be paid with 3s and 5s, now with strong induction. The predicate doesn't change. With the base cases, we now have 3 base cases corresponding to the cases that came out from our well-ordering proof. We will look at n equals 8, 9, and 10. So for 8 can be made of 1 3 and 1 5. 9 can be made of 3 3s. Here we don't have any 5s. And 10 can be made out of 2 5s. So here we don't have any 3s. Now, induction hypothesis is really what differentiates strong induction from regular induction. Let us assume that for every amount I from A all the way up to k minus 1, you could pay it with y sub I 3s and z sub I 5s. Now from that much stronger assumption, let's show that P of k hold, that we could pay k with 3s and 5s. So first, since k in the induction hypothesis was greater than our large base case, we know that k minus 3 is greater than a, because we have 3 base cases. So by induction hypothesis, k minus 3 is between 8 and k. So the induction hypothesis applies to it. That is, k minus 3 can be paid with y sub k minus 3 3s and z sub k minus 3 5s. The proof is very easy now, because if you know how to pay k minus 3, it's easy to pay k. We just add another 3 to it. And that's it. That completes the proof. So you see, with a stronger induction hypothesis and with more base cases, we greatly simplified our proof of the induction step.